it's Ms. Phoebus, and this is Lesson 16, Domain and Range of Continuous Functions. We are going to be looking at the set and interval notation that we used yesterday, but this is for continuous functions. Continuous functions. That means that I have a graph, I have a line. This is different than a table or a set of points. With a set of points, you are still going to be doing, and you should be using your little braces, especially if you are typing them in the computer. I understand if they're hard to write on paper, but you are typing them in the computer, and you are separating them with commas and things like that, no repeats, and you are making sure that that is for your discrete functions. This is not going to change. What we're talking about today is not going to change what I've already told you about the discrete, the dots, the mapping diagram, the tables, the set of order pairs. All of that is still going on. And some people are going to try to do the domain and range that we do today with the lines and try to do the same exact thing with the dots. You can't do that. I'm going to be able to tell if you were listening to the video. So you need to put in your notes that discrete domain and range looks like this. Continuous domain and range with lines looks like this, something different. You are responsible for knowing the difference. You're going to know the difference because you watched this video, right? You wrote this in your notes. You look at your notes when you take a test. Ladies and gentlemen, when you get back to school, if we come back full time, these tests and quizzes and stuff in the future will not be open note. So please take notes. Please use them right now. And then know that in the future, you're not going to get them. You will be expected to know and have all of this memorized. So I would definitely be taking advantage of that fact while we're still virtual. All right, so let's get into this. We have, I think it's about 8 examples. And so in this video, there are 8 example problems. The last 3 are going to be the you try problems. So I'm going to go through several examples and I'm going to teach, and then I want you to practice on your own in the 3 you try problems and see how we do. All right, so today's lesson, the goals are, we're still going to check and see if we can determine if a relation is a function, and then identifying the domain and range of the functions on the coordinate plane, and then we're going to use both the interval and the set notation. Now, when it comes down to it, I really prefer the interval. You're going to see the interval a whole lot more for me than the set, but because you can find them in different places, written different ways, we are going to practice both in this lesson. We're still looking at this, understanding that a function, the domain and the range, how they're related to each other, how it goes along with a graph, all that kind of stuff. So we're still looking at breaking down this standard about domain and range. So here we go, problem number 1. We have a graph, a picture graph here, and we have a line, nice straight line, and if you notice, we have arrows on both ends, okay? The line goes all the way across the coordinate plane, and I just want to tell you that if your line does go all the way across the plane but doesn't have arrows, you're going to assume that it will keep going. So sometimes you have, I'm going to draw another picture on here, but sometimes you might have a graph that does something like this and doesn't have arrows, but looks like it goes, this one definitely looks like it goes down here, goes off the plane, coordinate plane, but even if it doesn't have arrows, it is still, it's like it has arrows. So just keep that in mind. Even though the arrows may not be present, the function or relation or whatever it is may keep going. If it is going to stop, it's going to stop well. So like if I had something like this, it is going to have a definite endpoint. You will be able to see that endpoint. So just because it doesn't have arrows drawn doesn't necessarily mean that it doesn't keep going. It will keep going if it's on the edge of the coordinate plane. All right, so the question is this a function? Does it pass the vertical line test? So I'm going to drop some vertical lines, and I'm looking for any place, I'm not like avoiding any place where it wouldn't cross just once. It looks like it's crossing one time every time that I drop this vertical line, so yes, it is a function. Now tomorrow's lesson is about what family these functions belong to, and this is one of our function families we'll talk about tomorrow. Now, why is it a function? It passes the vertical line test. You can say that. You could say each x has only one y, has only one y. Okay, those are good statements about what's going on with our function. All right, here's the domain range part. I have one blank, but I'm going to do the interval notation, and then I'm going to go back and talk about the set notation. So with the domain, again, I would be using my arms a lot, pointing to the left and the right. But remember with our interval notation, it's the smallest value or the smallest number that we would reach, comma, the largest number. Okay, and then you have brackets or parentheses or something like that. That's what we're talking about now. So when I talk about domain, I'm talking about x values. And with x values, I'm talking left and right. And this is like the kind of stuff you need in your notes. When we're talking range, we're talking y values. And y values are up and down. Okay, so I'm going to break this into two ideas. I should have used my little slash there. I was in my way. In my own way. I can't see because of my own shadow. There we go. So anyway, the domain are x values, left and right. The range are y values, up and down. So I'm going to break it into two ideas. I'm going to approach it first with how is my function, how far left is it going to go, how far right is it going to go, and then wrap up that idea. And then I'm going to go back to my function graph, and I'm going to ask myself how far down it goes, how far up it goes. So I should probably have, instead of up down, I should have down up, because remember it's smallest, and if I go down, those are those negative numbers, and then up would be the positive numbers getting larger and larger. So I still didn't do my little slash. There we go. Anyway, so I'm going to think of it as two kind of separate ideas, two different directions, because we are in two dimensions. This is a two-dimensional plane. We have left and right in our x-axis. We have up and down in our y-axis. So we need to talk about the domain and range as two separate ideas. All right, so here we go, getting started. How far left on this function does this function go? So what sometimes I like to do is I like to think there's a little person on this function, and they're going to walk to the left. How far will they walk to the left? Well, they will get to keep going and keep going. They're going left. Yes, they're going down, but they are going left in this fashion. And because of the arrow means that they're going and doing that forever. And what number is all the way left on the number line forever? Negative infinity. Comma. And then we turn the little person around and say, okay, you're not going left, you're now going right. So let's get rid of that. And you're going right. Little person, I want you to walk right until you can't walk right no more. So they're going to be walking right. And as they're walking right, yes, they are walking up. But we're going to keep going right and right and right and right and right forever. That's what that arrow means. So what number's out to the right forever? That number is infinity. Now, from yesterday, I told you that infinity always gets parentheses. Okay, always. All right, let's go back to range. Okay, so domain was left and right. Now range is up and down. So we're going to look and we're going to say, okay, little person, I want you to walk down as far as you can to the smallest number that you can possibly walk. So they're walking down. Yes, they're walking left, but they're also walking down. And how far down? Well, the arrow indicates forever, and negative forever is negative infinity. It gets a parenthesis. Now I say, okay, to my little person, all right, little person, oh no, you got erased. Your poor head. There you are, okay? Now I'm gonna send you up on this graph. I want you to walk this line, walk up as far as you can, and tell me when you stop. Well, that arrow implies he's gonna be walking up forever, so he's not gonna let me know he's done until he reaches infinity, okay? So domain and range, negative infinity to positive infinity, and that was how we would read it. If we were doing domain and range with our inequality notation, we are between two values, so domain is x, and we are between negative infinity and positive infinity. There is no equal to bars, but there are always less thans when you do these and compound inequality ideas. You're between two values. Now for range, and this is the part that's different. Everybody, for some reason, wants to put x in between, but range are y values. So when you write this, y is in the middle. So that is definitely something I would add in my notes. If I'm doing range with my inequality notation, I need to make sure my y value is used. I use the letter y. Why? Because that's the letter that's for range. And yes, I do those jokes all the time. All right, so that's domain and range in both the interval notation and the inequality notation, the set notation. Let's get another one. Oh no, I'm running into things. Okay, here we go. Oh, look at the pretty circle. Okay, question is it a function? So I'm gonna drop a vertical line and there's one here and here. It does not pass the vertical line test. It fails. So is it a function? No. It fails the vertical line test. You can say that. You could also say it has repeating x's. You could say each x doesn't have one y value. Okay, you have lots of options, but you need to be able to say one of them to me and be able to write it in a sentence. Hint, 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 hint. Just saying. None of this choose from a selection. You may have to write a sentence. Anyway, domain and range. So remember, domain is left to right. Range is up and down. Okay, so we're going to go smallest to largest. So if I'm on this graph, looks like this is the furthest left I go. So that looks like -2 on my axis. And then this is the furthest right I go. That looks like it's 6. So I'm between two values. My smallest value is -2. Remember, it's always smallest, comma, largest. The largest value is 6. And I can actually touch those values. I don't have any open circles anywhere. I actually have parts of my graph at those x values. So because of that, I get these, somebody called them staples. I get these staples, these brackets, okay? And I really can do that when I can touch. And I can say, if I touch with my finger, it's not going to work. Let me touch with the blue marker. I can touch right here and I can say, yes, that number, that's a part of my graph. Yes, this number, it's a part of my graph. And so because of that, I can touch it. It gets brackets. I can't touch infinity. I can't touch negative infinity because they're not really numbers. But I can touch -2 and 6 on my graph. All right, that takes care of domain. Let's look at range. Remember, it's always smallest to largest, so I'm going to go down. Looks like down here we're at -6. And then the largest, the highest point that we reach is 2. So we're going to go smallest to largest, so -6, comma, the largest is 2. Again, I can touch them, I can point to them, I can say, hey, look right there, this point, -0, -6 is a point on my graph. So because of that, I get these brackets. All right, so that's the interval notation. Let's go back and let's look at the set notation, the inequality notation. And so what that's going to look like is I'm going to have x in between two less thans with -2 on the left, 6 on the right, but because I have those brackets, I'm going to give these guys equal to bars. All right, for the range, I'm going to have -6. I'm going to have less than or equal to because it's got the bars there. I've got y less than or equal to 2. All right, so that is our domain and range. You need to be able to write both. We're going to look at some more examples. Let's do number 3. Number 3, is it a function? So let's see, does it pass the vertical line test? Looks good there, and there, and there, and there. So it's looking good, yes. It passes the vertical line test. Remember that there are other options that you can state. Now let's look at domain and range. This is one of our function families that we will talk about tomorrow. But remember, domain is left to right, range down to up. Okay, so let's think. Here's my little person. I didn't have them walking on the circle, but I want to send this little person to the left. How far left would this person be walking? Now they're going up very quickly, but if you notice that the function is going left, it's going left very slowly, but it does keep going. And so it's going out left to -infinity. And -infinity gets a parenthesis. All right, let's turn this person around. And instead, we're going to send them to the right. How far right can they go? Well, they are going up quicker, but if you notice, the graph is going out to the right a little bit. So, and it's going to do that forever because of that arrow. So we've got a positive sign. Move it up. All right, let's look at down. Okay, person, we want you to walk down. How far down can you go? Well, it looks like the furthest that the person could reach is here. It's like there's a curve. It's like there's a curve. There is a curve there. There's a bend, right? It's going down and then it's going back up. It looks like it's got a y value of -4. So -4 is something that I can touch. It's the lowest point on that graph, so it gets a bracket. And then now I'm going to turn my person around. Instead of going down, I want them to go up. How far up can you walk? Well, either this way or this way, doesn't matter, but you see those arrows? It's going to go up forever. So it's going to go up to +infinity with a parenthesis. All right, so let's look at building these. So with my domain, very similar to what we did earlier, we've got our x in the middle, we've got less thans on either side of it, -infinity on the left, +infinity on the right. Now for range, it's going to be just a little bit different. You could put -4 and +infinity, kind of like what we did with this one, or really, we're just looking at all the y values that are greater than or equal to 4. That's a better way to do it than writing this. I don't like this one. Don't do that one. Do this one, because we're greater than or equal to 4. We're able to capture that infinity idea just by using one sign. So remember that it's all about doing things simply. And so y is greater than or equal to 4 is more simple than that compound inequality idea. So don't do this one. Don't do it. Do that one. Write it in your notes. I'd even write the wrong one in there and put an X and write don't do this. So then that way when you come back to it, fix it. All right, let's look at number 4. Does it pass the vertical line test? Doesn't look like it. Looks like it fails. Now, some people are like, oh yeah, it passes, it touches 1 point right there. But no, you're looking for, can it cross more than one time? You're going to go out and try to seek that. And so because of that, this is not a function because it fails the vertical line test. All right, domain, how far left and right? Range, how far down and up? So let's see, how far left can this go? Looks like this is the furthest left. If I put my person They're sitting on the graph now, but if I put them on there, they're gonna hit this, and then if they're like Spider-Man, they can go up on the ceiling. But you know, they're gonna hit this point, and they're not going to go any further left than it looks like -3. So -3 is the furthest left. It gets a bracket because I can point to it. And then the question is now, what's the furthest right? Well, because of the arrows, it's going to go right forever, so it's going to go right to positive infinity. So even though these are not functions, some of them aren't functions, you could still do domain and range. All right, range, how far down? Let's think down. So if we're going down, it's just like little bits, right? But we're still going to keep going down as we go with that arrow. So we're going down to -infinity. And then, again, if we had Spider-Man and we're asking him to go up, how far up would he go? He would keep going up. That's what that arrow implies. Positive infinity. Wrap it in parentheses. You're good to go. All right, let's look at the inequality notation, the set notation. For the domain, this is one where you can write it simply. I would rather you write x is greater than or equal to -3 rather than trying to put it into a compound inequality. This is preferred because I'm going from -3 to the right forever, just like if I had a number line and I had -3 here and to the right forever, it would be the same idea. All right, let's look at range. We're going from -infinity, less than y, make sure you got y in there, is less than infinity. All right, let's look at number 5, and I think this is the last one we do together. You're going to do 6, 7, and 8 on your own. Now, we're going to talk about this one again when we are on our function family, but here, let me draw my little person. Touch the line, come on. All right, so here's the function in case you don't, and I'll go ahead and tell you it is a function because it's on passing my line test, but it might be hard to pick out because it kind of blends in with the graph a little bit. It is a function. It passes the vertical line test, but it is a nice horizontal line, nice and flat. Okay, so if I asked you how far left the person on my line could walk, they would go left forever to -infinity, comma. If I asked you how far right this person could walk, you would say forever to positive infinity. Close those up with parentheses. Here's the difference, though. I'm going to get rid of this for a second. Let's look at the up-down. This one is interesting. Now he's grown. He's getting taller. Yay. Okay, how far up and down will this guy go? He's not going to go up and down. He's going to stay nice and level. And he's at this -2 y value, and he's going to remain there. So there's only one y value. And so we're just going to put -2. And there's not a smallest, there's not a largest, so you don't do a comma. There's just one y value. So write that, surround it in those brackets, and then you'll be finished. Okay, let's look at the inequality notation, and then that leads us to, in the range, a little bit different story. But we've got our -infinity is less than x is less than infinity. And then for our range, we don't have a range of values. It's a different kind of range that I'm using there. We don't have a span of values that we're talking about. There's just one. So we're just going to write y equals -2 because there's just one value. I'm not looking between two numbers. I'm not looking above or below. It's just one value. So it gets an equal. That's the only time that it happens, though. If there's one value, will you get an equal sign? All right, so I'm going to do some pausing at the beginning of each of these problems. And you are going to try to do these yourself. If you'd like to sketch the graph, you can. But remember that in the future, if there are no arrows, there are arrows in this one. If there are no arrows, but it does look like it goes off the graph, there are implied arrows. So you're going to try 6, pause the video, try to answer these questions now. right, so hopefully you're back. Is this a function? Yes, it is a function. It passes the vertical line test. Crosses once, crosses once, crosses once. It's getting really steep on the ends, but it's still going to cross just one time. And this is, we're going to talk about them tomorrow. This is one of ours in our function families. And so, yes, it is a function because it passes the vertical line test. All right, let's look at domain. So how far left can this function go? If you notice that it is getting steeper and steeper, but it is getting closer and closer to this value, and it's going to it's like going to be tiny fractions of movement. But because this is getting closer and closer to one of those values, it is going to be going left forever. It's just going to take a long time to get there. So it goes left to negative infinity. And then the same thing out here, if you notice that it's going to the right, it's like really, really small. But it is still moving to the right. It's going to go off to positive infinity. Wrap those in parentheses. That one's done. And if it's not going off to infinity or negative infinity, it is going to be just obvious. You're going to be able to see it. All right, let's talk about down. This one's definitely going down forever to negative infinity. And up forever to positive infinity. Now, some of you may think that, these pieces are important. They are important, but not to the domain and range. And when we talk about key features or characteristics of functions next week, those things are going to be things that we talk about as far as relative maximums and minimums and things like that. They are points of interest. Let's see if you got your inequality notation down. Throw an x in between a negative infinity and a positive infinity. Can't say infinity. And then for your range, throw a y in between a negative infinity and positive infinity. Pay attention to your inequality symbols. Do they look right? Okay, let's go and look at number 7. Pause the video. All right, so let's look at this. Does it pass the vertical line test? Looks like, nope, it fails. So it's a function, nope, it fails. Vertical line test. All right, let's look at domain and range. So how far left does it go? Looks like this right here is the furthest left. So that is an x value of -4. And I can put my finger on it. It is a point on this graph. And then let's look at how far right it goes. Now, right here is the furthest right it goes, 3. But do you see this open circle? So there's not a point there. We can get really close to it. So that goes back to the idea of open circle, closed circle. And so what we're going to have is we're going to have a comma, 3, but that 3 gets a parenthesis. All right, that's left and right. Let's go back to down and up. I always want to say up and down. So how far down? Looks like right here. That's the furthest down. That's a y value of -5. But because there's an open circle right here, it's going to get a parenthesis, comma, how far up? Looks like right here, there's a y value of 5. It also has an open circle, so it's going to also get a parenthesis. Let's look at the inequality notation. X is in between -4 and 3, but the -4, because it has the bracket, gets the equal to bar. The 3 has the parentheses, so no equal to bar. For the range, y is going to be between -5 and +5. Remember, always the smallest number on the left, the bigger number on the right. And then no equal to bars because both of those are parentheses. All right, I think we got one more. And we're going to talk about this again tomorrow, domain and range, so just keep in mind. This is coming back. It's not going away anytime soon. All right, is this a function? It looks like a W. It is a function because it's going to pass the vertical line test. So yes, it's a function. Passes the vertical line test. All All right, let's look at domain. How far left is this thing going? I can put my person on there if I want to, or I can just think about how far left it's going. And if you notice, it's getting really close to this x value. So it is changing. It's going to be getting steeper, but it is going to change a little bit. So it is going from negative infinity. Let's see how far right. It is getting closer to that x value. So it's going to positive infinity. How far down? Let's see, looks like right here it's not going any lower than this, and this is a y value of 0, and because it's a 0 and it doesn't have any open circles or anything like that, we will put 0 there with a bracket. How far up? Looks like this thing's heading up forever. We're going to infinity and beyond. I get my Buzz Lightyear jokes in there. All right, domain. X is between negative infinity and positive infinity. Y, however, because we're going off in one direction, greater than or equal to 0. All right, guys, domain and range of continuous functions. We're pulling yesterday's lesson in. We're getting ready to be graphing functions and lines and things like that, and we're just going to try to marry the two together. This idea is not going to go away. We are going to go more in depth with each individual function in our function family, and this is going to come up quite a bit. So if you are having questions, you need to make sure you're asking and making sure you're watching videos and taking notes. I'll see you guys in the next video. Bye.